Hey everyone. So today we're going to talk about properties of vectors. So here I have written three vectors, u, v, and w. And k is going to be representing our scalar. Now as a reminder, a scalar is just a constant. Okay? It's something that scales something, makes it larger, makes it smaller. Okay? So this is just considered a constant. Now, a couple of properties that we want to talk about, the very first two, is u plus v. That's where we take vector u and add it to vector v. Now, I have up here represented three vectors, u, v, and w. And just saying that, w1, w2 would make up that x component and that y component. Okay? v1, v2, and u1, u2 would make up those x components and y components of their vectors. Now, when I have vectors being added together, as simple as I can make it, you literally add their terms together in a sense. So their x's together and their y's together. Okay? So you would take u1, in this case, plus v1, and you would have that added together, and then you would add u2 plus v2. So all you're doing is adding the x's together and adding the y's together. It's as simple as that. The second most common property would be k times vector u. So k times vector u is literally k times the vector u1, u2. Now that constant is a constant to the whole vector. So it's kind of like you have to distribute it, and this is one of the only times that we really distribute things in vectors, is we say that I have k times u1 and k times u2. You would distribute it to both. It's pretty straightforward, it's pretty simple, and it's pretty easy. So let's move on to an example. Okay, for this example, I have two vectors again. I have v, which is negative 2, 5, and w, which is 3, 4. So for this one, I have three things that I want to do with it. The first one is 2 times v, times vector v. And that would be kind of like our k times u up here. So we're going to take 2 and we're going to multiply it to vector v. Now vector v is negative 2, 5. So I actually literally just write it out as is. And then I multiply in the 2. So 2 times negative 2 is negative 4. And 2 times 5 is 10. Done. Okay, that would be the answer for that property. Okay, so what they're asking you to do there, that notation, that would be my answer and I would be finished. W minus v would be taking w, which is 3, 4, and subtracting v, which is negative 2, 5. Now, the way I would subtract this is I would subtract the x's and I would subtract the y. But without taking it out of the brackets. So 3 minus a negative 2 and 4 minus 5. 3 minus negative 2 is 3 plus 2, so that would be 5. And 4 minus 5 is negative 1. My answer for this one would be 5, negative 1. Not trying to overcomplicate things or make it too simple, but that is really all it is. For this one anyway. The next one down here, if we move down just a little bit, I have v plus 2w. Now v plus 2w would be taking vector v, which is 2 or negative 2, 5, and w, but multiplying w first by 2. Remember that order of operations applies, okay? Order of operations applies. That is that whole PEMDAS thing. If you, what do you call it? If you remember it, PEMDAS. Please excuse my dear Aunt Sally. Parentheses, exponents, multiplication and division, and addition and subtraction. So before we can do the addition, we have to do this multiplication piece. So I would distribute the 2 here first before I can add. Negative 2, 5. Plus multiply 2 times 3, which is 6, and 2 times 4, which is 8. Now I add them together. So now that I've done the distribution of the multiplication, then I can add together my other terms. So I have -2 plus 6 and 5 plus 8. Remember, x with x and y with y. -2 plus 6 is +4, and 5 plus 8 is 13. And there you go. That would be one complete example of how to use those two properties above. I'm going to show you in just a second. So if you want to pause this, you can, but in just a second, I'm going to show you all the different types of properties that we have. Okay, so give me 2 seconds. Okay, and here are those additional properties. So these are all properties of the original property that we just talked about. So the u plus v1, which is u1 plus v1, and u2 plus v2. And then the k times the u1, where you can distribute k, which is the scalar. For this one, a couple of things to note. If I have two vectors and I'm adding them together, u plus v is the same thing as v plus u. Those are interchangeable. And here, the same thing can be said for when I'm adding 3. So I can do u plus v together first, then add w. Or I could do v plus w first and then add u. This 0 with a vector over it is actually called the 0 vector. I wrote it above. 0 vector is 0, 0. So I have u plus the 0 vector is just u. Makes sense. U minus u is the 0 vector, so that would be where everything cancels out, but you're still left with a vector. Here I have two constants being multiplied to the vector. You can either multiply one of the constants first and then the other, or you can multiply those constants together and then multiply that number by the vector. So it's however you kind of want to do that. C plus d times u, I can either add them together first, then multiply times u, or I can take c times u and add d times u. So these are also scalars. And the same can be said for this one here. C times u plus v is the same thing as c times vector u plus c times vector v, and so on. Now we're not going to go over examples of all of these properties. They're pretty straightforward, adding and subtracting, multiplying and dividing, but I do want to go over one additional example with you. So here's that example. So here there are actually two ways to do this example here. I have the magnitude. Now remember how to find magnitude, okay? The magnitude of any vector is the x component squared, so that would be v1 squared plus v2 squared, okay? The square root of that. So as a reminder, we need to know how to do magnitude here, but this is saying the magnitude of c times v. So there's actually two ways to do this, and we're going to do both ways real quick. But the first way is to take the c, which is our constant, 3, and to multiply it times vector v, which is going to be 2, -5. So we can literally just say, okay, this is going to be c times vector v, and then we'll take the magnitude after that. So we do it in stages, kind of working from the inside out. So 3 times 2 is 6. 3 times -5 is -15. Now I want to take the magnitude of this. So to take the magnitude of this, I'm going to square root 6 squared plus -15 squared. So we multiply by our scalar, and then we square root and square everything. This should simplify to 269. Now this is a really large square root that we could possibly simplify. So as a reminder of simplifying square roots, we take it off to the side, and we say 261 is the same thing as 3 times 87. And 87 is 3 times 29. Now I know 29 is a prime number, so I can't do anything there. But this is the same thing as if I multiplied 3 and 3 together, 9 times 29. To finish this off, the square root of 9 is 3, and we would say that this whole thing simplifies to 3 square root of 29. So that could be your answer here. And that is one way to find your answer, is to multiply that scalar first in and then simplify. But another way to do this which I really think is important to point out, is that instead of multiplying the scalar first to the vector, we can just multiply the scalar to the magnitude of the vector. So instead of multiplying it by the vector first, then taking the magnitude, we can actually take the magnitude of the vector and multiply it by that scalar. So watch how this works. We would take and find the magnitude first. So this would be 3 times the square root of the magnitude of v. Now the magnitude is found by taking the x squared, which is 2 squared, plus the y squared, which is negative 5 squared. So this would be 4 plus 25. The square root of 4 plus 25 times 3. So 4 plus 25 is the square root of 29. Notice that I actually didn't have to simplify my radical here at all, and it is a simpler way of doing it. So that is one thing that some of these properties make it easier, is to sometimes do that multiplication piece last. And this is not up here in your property list, but it is something that I wanted to make sure it was noted. But you're going to have lots of different things that you'll run into. A lot of it is common sense in the sense of math, mathematical properties that you've done forever, adding and subtracting, multiplying and dividing, all of those different things. So just make sure that you're following the properties. The main ones are the ones that we talked about earlier on in this video, those first two where I have u plus v and k times the magnitude, or the vector u, or vector v. It could be k times anything. But this I felt like was a good example to kind of put out there, because it shows you 2 different ways to do something. That one is a little bit harder because you have to simplify that radical, and one's a little bit easier. So yeah, that's it for today.